the powering, the propulsion part. So the Reynolds number we already covered, but in more detail, it is a ratio between dynamic pressure and frictional stress. So that the meaning of Reynolds number means high Reynolds number means lower friction, and also they're developing a vortex, and also momentum flux or mixing of momentum by vortices, and diffusion due to this vortex and momentum changes. This is the video. This is slow laminar flow. Sorry, I guess I did not check the audio part. Okay, let's go on again. It's not moving. What's wrong with this? Okay. Okay, that's it. So that is the meaning of Reynolds number, and there is another one, Froude number. In terms of forces, it is ratio between dynamic pressure, same as previous dynamic pressure, but also the bottom is gravity rather than frictional. So high Froude number means low gravity effect, and free surface is more deformed, and static pressure or dynamic pressure is relatively small. For planing hull, this is the planing hull. So high-speed boat is planing above or slightly above the water instead of a submerged one in slow speed. So when the boat is slow speed, the level of height of the boat is low, so it is fully submerged. But when the speed is going up, very similar to ski, water ski, it is planing, start to planing, so that the ship is going higher above the water. Right? Around here. So that is supercritical, subcritical, or water jump related to the Froude number. And devices, propulsion devices, we see the propeller, you see the size, because the human in front is comparing. So you can expect that diameter of the propeller can be 10 meter. Right? So a screw propeller is trying to convert torsional energy from the shaft into thrust. Thrust means the pushing forces, pushing that pushes the ship. Each blade of the propeller slices water and impacts backward thrust. Slice means angle of attack, very same as the airplane wing. So this is a zero lift line, same picture we can see from the airplane. And there is a propeller related terms. So suction and pressure side, suction and pressure side. So this is a face and back. So when they push down the water, then the pushing face is pressure face, and the other side is a suction side. And leading edge and trailing edge, the edge of the sideline of the propeller, we call this is a leading edge, where they push or into the water, and trailing is following the other side of the edge. And hub is center where the shaft is going, and hub and root is similar, right? So root part is a little bit of the blade, and tip is at the top, right? So tip and root and hub. And diameter is here, diameter size of the propeller, radius. And pitch is the angle of attack, and also sleeve, skew, rake, we'll see in the later stage. And same terminology, but with a different picture. See. And then the skew is like this one. Skew is the propeller itself is, this is a curved one, not straight line. Previously, it looks like a straight, right, center line. But here, this one is also have a very high skew. Right? So skew is the blade itself is not straight in the center line. And then where else you can see, this is highly skewed propeller. And then there is a suction and pitch. Pitch is angle of attack. Also the in bolt and nut, the bolt mount and pitch is one rotation, it goes to the pitch. That gives you expect angle of attack and also speed of the propeller. And different type of propeller. There's a fixed pitch propeller is a traditional one. A controllable pitch propeller is like this picture, so that the hub or root of the propeller can be rotated here. So each blade can be rotated so that the angle of attack or pitch can be controlled by the captain. And supercavitating, the propeller has, at any time they have a fully covered cavitation. Instead of collapsing cavitation, they do not collapse. Somewhere they slightly collapse, but it is fully covered by cavitation. So it's a very high speed. They are saying supercavitating propeller. And counter-rotating propeller means there are two propellers in series, so they rotate in different angles, in different direction. So there is one small video, so we'll see a little bit. Counter-rotating propeller. So this is cavitation tunnel, means experimental device to test the propeller. And there's a two propeller rotating in opposite direction. So we call this as counter-rotating propeller. All right, and then I stop. Okay. And there is another video for variable pitch propeller or controllable pitch propeller.
Did you promise yourself 2021 would be the year you'd be more productive? Get all your work and life organized?
Massive ships are powered by massive propellers. Likewise, small boats are powered by small propellers, but the principles are the same. One propeller is the controllable or variable pitch propeller, but how exactly does it work? This vessel is the Hermes. She's an old design deep sea salvage tug fitted with two propellers. I don't know what her original propulsion was, but I can use her for this demonstration and give her one controllable pitch propeller and one fixed pitch propeller. When they're spinning away like this, it's hard to see anything much, so let's slow it down and look at the controllable pitch. Like this, she's running ahead. The propeller blade is cutting the water and propelling it backwards. This is no different to a fixed propeller. When running ahead, they look exactly the same. The difference comes when we want to reduce the speed. To reduce the speed of a fixed propeller, you have to slow the rotation. Very easy if you've either got a gearbox or an engine that can easily vary its speed. It's a bit harder when your engine likes to run at a constant speed. A controllable pitch propeller, on the other hand, runs at a constant rotational speed. To reduce the vessel's speed, you change the angle of attack of each blade instead. It's hard to see while rotating, so let's stop it and have a closer look. Running ahead, you can see it's got a steep angle of attack. This makes it harder to turn, but generates more thrust. As you reduce the angle of attack, the engine has an easier time turning the propeller, but it generates less thrust, slowing the vessel. You can generate zero thrust by setting the pitch to 0. For example, this setting would be used when a ship has started her engines but is still alongside her berth, not yet wanting to move. By contrast, to set a fixed pitch propeller to generate zero thrust.
Let me stop here. Do you have a question? Then you can raise anytime. All right, there is another one. It is about control rotating. But this is not ship, it is air-based. So you can see that wake field, the stream outside afterward is more focused. All right, so, and then it goes to the cavitation and erosion. Right. Erosion is due to cavitation. Anyway, the speed of ship and also speed of the propeller increase, then it creates a low pressure because of the speed. Very similar to blade or airplane wing. And then because of the low pressure, water boils in lower temperature, even in water temperature. So it happens locally in a pump, in mechanical engineering, also on propeller blades, and also in a hydrofoil. So, and supercaviting propeller is fully covered with the supercaviting. Okay. And I guess there is another video. Oh. No. Oh, where is it? Where is it? Here is the good video, so I will show you. Something is wrong. My notebook. Okay. Show you the video this way.
Snap, crackle, pop, boom! That is the sound of cavitation destroying your propeller. That might sound overly dramatic, but cavitation poses a major danger to propellers. Collapsing cavitation bubbles release tiny bolts of extremely violent energy. That energy means death for your expensive propeller. So today we discuss the best solution to cavitation. Avoid it. How does this mystery of disaster work? Well, cavitation occurs when small air bubbles form against a propeller blade. See, the bubbles form because the water actually boils. We know that the boiling temperature of water will change depending on the pressure. Take a pot of water to the top of a mountain and it boils at a lower temperature than it did at sea level, all because that pressure is lower. Propellers, incidentally, lower that water pressure intentionally. They do this to generate lift. Catch is, lower the water pressure too much and the water can boil at ocean temperatures. It'll create thousands of tiny little air bubbles that form against the surface of the propeller blade. But these bubbles don't last very long, and when they collapse, it works like a tiny explosion against the propeller blade. If your propeller has major cavitation, it has to endure the equivalent of thousands of tiny micromines exploding every minute of its life. So cavitation is bad, and it arises from large changes in pressure at the propeller. But a propeller does not create a single uniform pressure field. The pressure varies along the propeller blades and the root due to many interacting parts of the propeller geometry. For this reason, we classify the different types of cavitation based upon the section of the propeller that generates those bubbles. I'm going to focus on two major types of cavitation: bubble cavitation and sheet cavitation. Bubble cavitation shows up as some small region of damage in the middle of the propeller blade. Now, the key here is it's a small region that's clearly isolated from the rest of the blade. This occurs due to uneven pressure distributions along the blade. Somehow, some section of the propeller created an excessive pressure loss, resulting in cavitation. Now, this might occur due to interactions with the vessel hull. See, the hull also creates an uneven flow of water that enters the propeller. Some radial sections along the propeller have a faster inflow.
Okay, that's enough for the meaning. So that again, the screw propeller has a fixed pitch, control pitch, control rotating, and supercapitating, and they what's happening? This one. Okay. All right, and then supercapitating, the characteristics are here. Other propulsion devices, there's a paddle wheel. It's the old days in river. They use paddle wheels like this one. And air propeller, air cushion vehicle, put airplane propellers. And cycloidal or voice Schneider, they rotate in different direction. And then there is also magneto-hydrodynamic propeller. There is some video, so you may see probably in later stage. Right, so, and this is a pedal wheel, and also this is oh, there's a video. Probably we can turn on. Pedal wheel, and then also air cushion vehicle. Air propellers behind. So they can run on above the land side together with the water side. So amphibious means they can drive either water or land. That's convenient. All right, and then Schneider, Voice Schneider propeller has in vertical rotational, so they use it is good for tugboat rather than tugboat. So they can change their direction easily. That is the merit. And Voice Schneider propeller is working in this way, and they provide lifting forces so that they give motion in reverse way. And magneto-hydrodynamic propeller, it uses magnetic field inside the water fluid. So it is similar to electric motor, but they use magnetic field inside the water. So anyway, they use electric energy. So MHD propeller is not popular yet, but they are the people are working on research to develop this one. And Japan actually has a pilot propeller and ship to use by MHD. Okay, so you need, but this one is problem of superconductive material to develop this high energy, high power to propel a ship. You need a high power, so you need a special material for this. And there is a video you can see in the later stage. Thank you. Questions? All right, so then we may go on to Sungmin lecture. I need to allow you. Host. Okay. There's a chatting. There's a question. I have a question about fixed pitch propeller. Boston thrusters used in conjunction to rudder to maneuver, or are the side thruster used only to maneuver in port? Whatever they can use, they use. The captain use whatever they have. So usually if there is no thruster, side thruster, they only have main propeller and rudder. That is the only way. But the maneuverability is not good. If the ship has a side thruster, then captain has more power to maneuver. So captain is trying to use anything he has, everything he has. That is the usual way. Okay. So let's go ahead with those. Sungmin? Oh, other message coming. Okay, thank you. Sungmin, go ahead, please.
Do you see my screen? Yes.
Yes.
Okay. I will start my lecture. The topic is choosing propulsion machinery. Yes. Content is as follows: overview and alternative systems and generating electricity and fuels. SNAME means the Society of Naval Architecture and Marine Engineers. This term, engineers, means the ship engine expert. This is overview. Prime movers is about the main engine and propulsion system and transmission system to adjust the speed and power, and auxiliary machinery, generator, electricity generator, and boiler for steam turbine, and HVAC. This means the heating and ventilation and air conditioning and fuel. This is the alternative systems. Single and multiple screws and prime movers and transmission and alternative combination. Alternative combination is the hybrid system for mix dual engine, for example, dual engine, and considerations and overall considerations. This slide shows the single and multiple screws comparison. There are several advantages for single screw. It has the very simple structure because it has one axis and one simple gearbox. So it is easy to control the engine, and it has the better propulsion efficiency due to the small energy loss. Next, multiple screws. Compared to the single screws, it has the it generates the high power system because it has the two screws. So naturally, it generates the more power, and it could generate the better maneuverability because it has the two rudder. So area for rudder is bigger than one single screw system. It is possible to adjust the wide adjust the twin screw. So dial for propeller is smaller than single screw. So it could operate at the shallow draft sea. In these days, turbine blade size for wind power system is getting bigger. Top figure shows the twin screw system. It has the 2 axis and 2 gearbox. But so there are some disadvantages and advantages compared to the single screw system. And bottom is the single screw system. It has very simple structure system. Yes, in these days, wind turbine size are getting bigger. Also, small electricity generate about 3 to 5 kilowatt. For the 118 meter diameter, wind turbine generates about 10,000 kilowatt energy. This slide shows the prime movers. That means the main engine. Main engine consists of the gasoline engine and diesel engine and gas turbine and steam turbine. Gas turbine is used for the small and fast ship, and but diesel engines is usually used for very big ship. For example, big container ship and big crude oil tanker, and etc. Gas turbine is used for mainly for airplane because it is very small and so efficient. And previous day, steam turbines are usually for the big ship. For example, Titanic ship. Next, in these days, nuclear powered ship is developed. And detail is yes, okay. And for the diesel engine, there is no carburetor, but gasoline engine has the carburetor. For gasoline engine, that is separate injector, but for the diesel engine, by high pressure, the combustion is performed. And two-stroke and four-stroke engine. Two-stroke is smaller and lighter, but less fuel efficient, and two-stroke engines generate the more pollutants than four-stroke engine. Gas turbine, as I mentioned previous, gas turbine engine is used for the airplane because it is very compact and light engine. There are two classes of gas turbine engine, aircraft and power plant. Let's see the short movies.
그 소리가 안 나옵니다.
그래요? 네. 어, 죄송합니다. 다시 한번 해볼게요.
그 공유 해제하시고 다시
예.
공유하실 때 그
네.
옵션이 있을 거예요. 체크박스가
아.
있을 거예요.
네. 들리시나요?
Today, I'm going
네,
to show
잘
you
들립니다.
the ship's engine room. As always, we need some safety gear. Most importantly, earplugs because the engine room sounds like this. There's a few entrances. The most used one is from the engine control room. So let's start from there. A good number of computer systems and control panels are linked to the engine control room, so the engineers can work their magic from here. Through the fire door, we're into the actual engine space. Let's start off with the main course, the main engine. The whole engine is massive, 4 deck high. It can produce 80,000 horsepower, up to 25 knots in flat seas. Forget about the puny V12 Lamborghini engines. Our ship is also V12, but the piston rods alone are twice the size of a human. And you know what they say about large rods? The cylinders are even bigger. You might be wondering, where's all the crew? Well, unlike the past or future, all cargo ships nowadays, except for passenger and military, are designed for minimum manning. We're talking about 20-something people here on a 400-meter ship. At the back is the flywheel. All that power is transferred to the propellers through the shaft. And the big block is what we call a shaft generator. At a high enough RPM, we won't even need to use the diesel generators at all to power the entire ship. Speaking of diesel generators, we've got 5 of them. There's numerous machinery systems in the engine room. As a deck officer, some of them I didn't even know existed, but I can definitely bring you to the few important ones. Remember that time when I went into the duck keel? As you can see, the machines are placed in a way with only economics and safety in mind. There's no decorations at all, no room for luxury. The systems are in their pure raw metal form for simple execution. And the engine workshop is no exception. It's big and is well equipped. Near the shaft, and it provides another means of escape other than the entrances. However, it's quite a climb. Once you have made it to the very top, you'll come up onto the upper decks of the ship.
Okay. Next slide is about the diesel submarines. Actually, diesel engines are used only on the surface because to explosion, diesel engines need some air. So it is only for the surface, on the surface. But in underwater, to supporting the diesel engine, instead of diesel engine, it is needed the electrical storage batteries that is used to propel the submarine when it is submerged. It is charged. Charged on the surface, and underwater, instead of the diesel engine, it is instead of the diesel engine, the electric storage batteries are used to propulsion. This is the nuclear submarine. Typical nuclear submarines can travel 60,000 nautical miles before exhausting initial nuclear fuel supplies. It corresponds to the amount of that can make a round trip around the Earth. Usually, nuclear power plants capacity is about 1 gigawatt. So it is very big capacity. Nuclear marines use the uranium as a fuel, and making it possible to downsize the reactor. So in these days, small nuclear submarine could be made. Top figure shows the gas turbine, and left down figures on process for the explosion. First of all, air inlet, air entered the chamber and compressed the blade generate, and air and pure mixture are exploded in combustion chamber, and by rotating the turbine blade, and electric generator generating system generate the electricity. Right bottom figures are 400 megawatt gas turbine system. As you guys showed, this its size is so big. It is the steam turbine system. It is so big size. It is similar to the gas turbine system. instead of gas, this system used the boiled water. Water is heated and converted to the steam, and by steam, could rotating the steam turbine, and by using the generator, it could generate the electricity. For diesel engine, there are three categories. First of all, slow speed range. Speed range is 75 to 250 RPM. This system is directly connected to the propulsion system, so it is no need to gearbox. And second, medium speed system. The speed range is 400 to 900 RPM. This is used for the power plants and train engine. Third, high speed range. Speed range is 1,000 to 2,400 RPM. It is used for the truck engine. For the battleship, there are two speed range, cruise speed range and top speed range. Cruise speed range is mild speed range. So when cruising speed range, the diesel engine are used, but in battle situation, the battleship need to top speed. So to gain the top speed, combined engine are used, diesel and gas turbine, to get the more power. This slide shows the diesel engine. Left top figure shows the medium-sized diesel engine, and right top side figure shows the very large size diesel engine, about 4th floor building height. My presentation is over. Is there any question?
Okay, thank you. So is there no question? Then we can continue on next slide set. So please unshare your screen, please. Stop sharing.
Yes.
All right. Okay, then my slide set then. Okay, this is second part of propulsion machinery. Okay, so we are covering the book and the chapter, what is it, 10, almost done. So after that, we will go on to ocean engineering textbook. So I will cover the generating electricity and fuels things. And see, you remember that the society in the United States, their name is Naval Architecture and Marine Engineering. So naval architecture, it traditionally covers only hull part, and marine engineers usually take part of engines, because in old days, engine is the most important for ships and also new to engineers. But nowadays it is mixed up together. So anyway, also there is a navigational officers and also engineer. So engineer started from related with the engine, right? So marine engineers. Okay, transmission. So propeller, engine connected, but usually engine is high speed comparing to the propeller itself. You can remember the RPM of your car, passenger car. And there is another idea of electric conversion, but usually it is not efficient comparing to the direct drive propellers. About 5 to 10% loss more. Anyway, the pink box shows that engine drives shaft and shaft drives propeller. This is a mechanical transmission. But for the electricity, the engine generates electricity, and the electricity is used to drive motors to drive propellers. But there is an advantage of electric conversion, and the layout, the maneuverability, and no shaft tunnel, and shock absorbing, shock coming from propeller. About layout, you may think about the electric car. Nowadays popular. Many of electric car does not have engine, so that the engine room of the car, the front panel, usually empty. So many electric car there is a storage space there in front of the driver's seat. So that is a layout, because electricity only use electric cable, and the motor is smaller, so you can put a motor somewhere near the tires. So why we need a transmission? Because of RPM difference, also the reverse engineering. Sometimes we need to go backwards, same as a car. You need to switch your gearbox to be rear, reverse mode. But engine is not easy to reverse the rotation, so that gearbox is to. Also, slow speed and high speed, you need to have a gearbox system. So this is a combination of engines and gearboxes and propeller. At left-hand side, you remember that steam turbine, diesel engine, combination of steam and gas turbine, combination of diesel and gas turbine, and only diesel engines, and steam turbine, gas turbine, and several diesel engines. In the middle, there is a mechanical reduction gear, direct shaft, and mechanical and electrical together, electrical only. And also there is a propeller as a fixed pitch propeller, or controllable pitch or reverse pitch, so that there is a transmission. And machinery, direct drive diesel, steam turbine, gas turbine, medium speed diesel. There is a 4 popular of engine type, and the economy of them, the relative first cost, is good for highest in direct diesel, direct drive diesel, because it is big, so highest value. But Present. Overall weight is also big in direct big diesel engine. Length also big, but fuel rate is very low. That's why big ships use big diesel engines. Especially they use very low grade fuels. And propulsions, reliability, durability, safety, like that. And horsepower range, the motors, outboard motor for the small boat, it is only 200 horsepower. Gasoline engines, 200. So you see that there's a Sonata car at the bottom. They have less than 200 horsepower. High-speed diesel for the bus or small ships is up to 2,000. For medium-speed diesel and low-speed diesel up to 60,000 horsepower. Gas turbine, 50,000. Steam turbine, 70,000 per shaft. So nuclear power usually use steam turbine. And this is a machinery arrangement in a research vessel or Navy ships are similar. So this is an diesel electric power. So there are 3 diesel engine, 111. That is a diesel engine produce electricity, and there are number 2 is motors, and it gives you propeller rotating. So there is one way of electrical propulsion. And in terms of gearbox, you see that there are 4 diesel engines, each 2 double connected to run the gearbox, and then propeller 1. And electricity inside the ship is similar to car, also similar to building. The need for electrical energy is increasing every day, every year. Something like a bow thruster and stern thruster, cargo handling gears, cranes, accommodation, hotel facility, restaurant, theater. So usually they have 2 generating units for normal use, and also additionally there is an emergency diesel generator. Okay. Fuels, there are different diesel oils. I not touch much, but the LNG carrier still has a small percentage rather than oils. So gas is increasing nowadays, but still oil is dominant. And diesel engine, there are components and ignition, fuel injection and piston, crank, and so it is well known to mechanical engineers like you. So I will not explain more. Fuel categories, fuel grade. Cars use gasoline engine, gas turbine, high-speed diesel, and medium-speed diesel. And for the low-speed diesel engine or boiler, they use very low grade. So there is several properties of fuel oil: heating value, ignition delay, density, degree, and viscosity, and safety, cleanness, something like that. So fuel oils, number 1, number 2, number 3, up to 6. For the car, passenger car, you usually use number 2 fuel oil. And big diesel engine, they use number 4 fuel oil. Wikipedia has more on this, so you have a time, you can see. And residual fuel oil, very sticky and dark in shape, color. So Redwood number 1 scale. This is used for low speed, big diesel engine. So that's why they are very cheap, economical. And there is a very standard on several standards which classify grade of diesel oils. So American Society for Testing and Material, number 1 diesel, number 2 diesel, number 4 diesel, and number 2 is for cars and trucks, number 4 is for low speed diesel engines that are covered. Right? Engine control room. See, now it is traditional old type of shape, but you already see that there are more and more monitors are coming into the control rooms. And I have one video, but I guess you already see this same video. So I will not cover this one again. Okay, that's it for today. Questions? No questions. We need a discussion by student leaded discussion. That's why. But next week, yes, we will have one discussion led by Gihan. Good. I hope to see this. All right, because today we do not have any break time in the middle, so we can stop here a little bit earlier than scheduled. All right, bye now.
Thank you, Professor.
Thank you.